So to find out what's happening, we're going to graph the inside first, and then we'll graph the absolute value. So 2x minus 1. That's a line, a y-intercept of -1, a slope of 2, so we'll go up 2 over 1, up 2 over 1. That's the graph of y equals 2x minus 1. When we're graphing the absolute value, hopefully you can see that this part isn't going to change. But instead of having 0, -1, that gets flipped up to 0, comma, +1. And it looks like this. Now, the key point here is going to be this x-intercept. How do we find that x-intercept, since when we drew our line, it wasn't one of the points that nicely occurred? So we can solve for an x-intercept by making y equal to 0. Move the 1 over, divide by 2, and we find out that this point is at 0.5, comma 0, or 1/2, comma 0. So now that we've seen what happens with our graph, we can write our piecewise notation. In your piecewise notation, there's always going to be, well, there's usually going to be one piece that doesn't change and one piece that changes. Okay, we've seen some graphs where the whole graph changed, and we've seen some other graphs where nothing changed in our homework. But in this one, we had part that stayed the same and part that got changed. So I like to start with the part that doesn't change, because that's your exactly same equation that you started with. Can you see that this was the part that doesn't change? When is that part? Well, it's going to have to do with our x-intercept. Can you see that's when all the x values are bigger than our x-intercept? So we write when x is bigger than or equal to 0.5. Then there's the part that got flipped up. That was this part right here, or this piece. Whenever you flip it up, it's just like making the whole original equation negative. So we had 2x minus 1, and if we multiply that entire thing by a negative out in front, that will flip it up. And that's when the x values are less than 0.5. The way, because it has to be a function, you can only have the equal sign with one of them. So I usually write the equal sign on the first one and not on the second one. If you did the equal on the second one, don't put it on the first one.
Okay, so it's one or the other.
It's one or the other, because as a function, it should only be one of those two equations. So first of all here, we're going to graph negative x squared minus 3x. We're going to get a little bit of a reminder of some of our graphing strategies. If you wanted to graph this, if you wanted to use completing the square so that you could have the vertex, we'd first factor the negative out of both of those and leave a space. What number would go in the first space? Plus 9 over 4. What have we actually done? We've actually subtracted 9 over 4. So to compensate, we'd have to add 9 over 4 there as well. And now this would become negative x plus 3 over 2 all squared plus 9 over 4. Not very nice numbers, but at negative 1.5, 2.25, we have our vertex. This parabola is going down. We could do the over 1, down 1, but we're already dealing with fractions. Okay? Things that we're going to need for this graph are our x-intercepts. How do we find x-intercepts? Make y equal to 0. How do you solve that equation? How do you solve x squared equations? Make one side equal to 0 and then factor, quadratic formula. Can you factor this? You can factor a negative out. Can you factor, is there any other common factor? An x. You can take a negative x out, leaving you with x plus 3. So if we say, where is this equal to 0? At negative 3 and at 0. So we go back to our graph now. I now know there's an x-intercept here at 0 and an x-intercept here at negative 3. And this original graph looks like this. What is our absolute value graph going to look like? Can you see that this part is going to stay the same? And these parts on the outside are going to get flipped up.
Do you ever have to know
Exact points on the curve up. Sometimes they'll ask for that. And again, if you wanted to, you could plug in, let's say I plug in the point 1. Negative 1 squared minus 3 times 1 will be 1 negative 4. And then over here, I'd have 1 positive 4. So if you're ever wondering another point, again, the table of values or just plugging in an x value will help you find another point. Now we were asked to find the piecewise notation for this. Well, we have our original function inside, which x squared minus 3x. What was the piece that didn't change? What was this section right here that didn't change? When did that happen? When x was between negative 3 and 0. So notice I put my equal signs on this one, so I'm not going to use equal signs on my inequality for the next one. And then the other parts that got flipped up, again, we can just rewrite our original function, and to flip it up, we'll put a negative in front. And that happened when x was less than negative 3 or when x was bigger than 0. So again, sort of to recap, what we're going to do, we need to find our x-intercepts. It's nice to draw our original graph and our graph that's been flipped, so you can say, I recognize what didn't change and what did change. And then you can write out your piecewise notation after that. Okay, questions you can do for practice. 8, 9, and 13.